So what's happening is the speed is getting exchange in the directions. Over here it is moving down, just after collision it will move up. Okay, and then what will happen, the speed keeps on decreasing, because see, for the second half of the journey the motion will be retardation, right? So it will be something like this. Why? See, the slope has to be constant, and slope is nothing but acceleration, which has to be since acceleration is constant, slope has to be constant. So remember, the slope of both the lines is constant. Slope of both lines same, right? So how to draw x versus t over here? That is displacement versus time. Initially I am choosing my origin when I am starting to count the motion, or I am starting to analyze the motion of the particle. So at t is equal to 0, my displacement is 0. Okay, now the displacement is increasing in the negative direction this time. Okay, so this thing I know that I have to move downwards. Yeah, one more thing to note over here is all these graphs which I am drawing, they has to be restricted in first and fourth quadrant. It cannot move to second and third quadrant. Why? Because time cannot be negative. We cannot do time travel. Okay. And the other thing is, for one particular value of time, we must be having one particular value of displacement, velocity, or acceleration. Again, we cannot do time travel. Okay. Alright. So getting back to this problem, over here we have drawn velocity versus time, which is the slope of the velocity time graph is constant because acceleration is constant. Now, the slope of xt curve gives us velocity, and over here velocity is taking multiple values. As you can see over here, velocity is taking multiple values. Therefore, one thing is pretty clear, the slope of xt curve cannot be constant. It has to be varying. So it cannot be a straight line. When I talk about x versus t, it has to be a curvilinear line. Okay. Now, what should be that curvilinear line? How should we know that? Okay. First of all, for first part of the motion, if we concentrate, what's happening is, initially the velocity is 0. So initially the slope has to be 0. Okay. And then what's happening is, velocity is increasing in the negative direction. Okay. So if we consider the speed, okay, what's happening over here is, the speed is increasing. So the slope has to be steeper as time passes. Okay. But what's happening over here is, since velocity is negative, so slope will be negative to start with. Initially the slope has to be 0. Okay, so remember, and over here since downward direction is negative, therefore my displacement will be negative to start with. So should I go upwards or downwards? Should go downwards. Okay, because my displacement is negative. Okay, and initially since the velocity is 0, the slope has to be 0. Okay, parallel to the t-axis, and then it is getting steeper. As you can see over here, the slope is getting steeper and steeper. Okay. Now at this point, that is the point T1, the slope is steepest. Why? Because magnitude of the velocity is greatest. Okay. Now after that, what's happening is, velocity is just changing its direction, or we can say that speed remains the same and velocity changes its direction. Okay. Therefore over here the steepness should remain same, but velocity should change its direction. Okay, so what we can say is, the slope will change from over here positive to, or in this case negative to positive. Okay, but the steepness remains same. Okay, so can I draw something like this? Okay, over here the steepness is maximum over here, so the velocity will be maximum, and then it is getting less steeper. Okay. See, there is a very big conceptual mistake in this. Okay, over here I cannot just draw a discontinuous displacement versus time graph unless there is clearly specification that object is transferred from one location to another, which is not over here. So displacement is continuous. So this is absolutely wrong. Over here we cannot draw something like this. Displacement has to be continuous. And as you can see over here, initially the slope is steepest and it is getting less steeper and steeper. Finally it is getting to 0, and it should be, right? Okay, the other thing is, as you can see, the slope is actually changing from negative to positive, and that should be because velocity is changing from negative to positive, and slope of Vt curve or slope of xt curves gives us velocity. Okay, so I hope that now you are pretty much comfortable in handling the graphs. I mean, first of all, my advice will be first analyze the motion, okay, then think in terms of slope, okay, how slope changes and how graph should change. First you have to be pretty clear about the motion. Okay, one small problem related to it, then we can move on. Over here, if I give you a variation of v versus t, something like this. Yeah, this is t, just rub over here. So this is the general variation of v versus t, and let's say I'm just marking the intervals. This will be t4, this will be t5. So we have 5 intervals, okay. What we need to find is, using this v versus t, I want to plot x versus t, okay. So we know velocity versus time graph. What I need is displacement versus time. So it's pretty easy if you draw part by part, okay. So I'm just marking the time intervals. By the time I'm marking the time intervals, try to visualize the motion, okay. Try to predict the motion, what's happening, okay. Okay, I hope that you rightly predicted. Let's verify. So what's happening is, the particle initially at t is equal to 0 have some velocity. For the time interval 0 to t1, it will have that constant velocity, okay. Then what's happening is, that velocity is decreasing, okay, and it keeps on decreasing in the time interval t1 and t3, okay. It reaches over here its minimum velocity, and then what's happening is, the velocity is again changing its direction, and it is increasing for the rest of the part of the graph, okay. This is one interpretation. Other thing is, in terms of displacement versus time, if you consider that let's my body is starting from this origin, okay, let's say it is moving in this direction as the velocity is positive. So for the 0 to t1, actually it is covering some displacement in the positive direction, since the velocity is positive, okay. So for t1, it is moving in one direction, that is positive direction. Again, my convention remains the same, rightwards positive and upwards positive, okay. So if the velocity is in the positive direction, the displacement will be in the positive direction only. So for 0 to t1, my displacement will be positive, so it will cover some displacement, and then see, after which what happens is, since the velocity decreases due to some retardation, okay. So okay, the question is, will it turn after traveling t1, or will it keep on going in the same direction, okay. Think over here. I mean, don't think that it will turn after traveling time 0 to t1, okay, because see, at time t1, it will have some velocity, okay. Therefore, if some retarding force is applied on it, that velocity will decrease in the interval t1 and t2, okay, but it will keep moving in the same direction. That means that the displacement keeps on increasing from 0 to t2, okay. The displacement will not change or will not decrease, it will keep on increasing between 0 to t2. Keep this thing in mind, okay. The object traveling in a rectilinear path will turn only if its velocity is 0, okay. So at t2, its velocity is becoming 0. So let's say this is some displacement during t1, and then it is covering some displacement in t1 and t2. At this point t2, its velocity is becoming 0, okay. Now since the retarding force is still acting on it, because retarding force is acting between t1 and t3, therefore over here now it will start moving in the opposite direction. Till t2, it is moving in the positive direction. After t2, since velocity at t2 becomes 0, therefore after which it will start moving in the negative direction. So up to t3, now it has gained some velocity, okay. Also it has moved some distance in the negative direction, okay. Now after this, what's happening is, again the direction of the force is getting changed, or we can say that now the acceleration is in the positive direction, but again it has gained some velocity in the negative direction, okay. So it will keep on moving in the negative direction till time t4, when its velocity is again becoming 0, okay. So after that, what will happen is, since this this force in the positive direction is still acting on it, okay, therefore now it will again start moving in the positive direction. Okay, so think about it. I mean, the this graph speaks 1,000 words. Okay, so you have to understand it. So accordingly, we will try to draw x versus t. Okay, so first of all, I am concerned with 0 to t1. Since the velocity is constant in 0 to t1, the slope of xt graph has to be constant. Okay, therefore what I can say is it has to be an inclined line, or slope has to be constant. For this time interval, slope has to be constant. By the same logic over here. Okay, and the other thing is, since the velocity is positive, therefore slope must be positive. Okay, so it will be an inclined line with slope positive. Okay, now at this point, as I told you, it will experience some retardation, but it will keep moving in the same direction. Okay, so what we can say over here is, initially the velocity is maximum and then it is decreasing to 0. Okay, so initially the slope has to be maximum and then it should decrease to 0 at t2, but up to t2 it should keep on moving in the same direction. It was moving in the positive direction, it should keep moving in the positive direction. Okay, so see, initially the slope is maximum and finally the slope is decreasing. I think the slope variation is clear to all. If not, you can first see this. Let's say we have two curves, curve 1 and curve 2. Okay, now think about it, in which of the cases slope is increasing as I move in the rightward direction, in which of the cases slope is increasing. Okay, see, if you see the curve number 1, you can see initially it is steeper and then it is getting less steeper. Therefore initially slope is maximum, and as we move along the right direction, the slope is decreasing, whereas in the second curve exactly opposite is happening. Initially the steepness is minimum. See, steepness is nothing but the tangent at a point. Okay, don't be confused. And as you can see that as I move in the right direction over here, the steepness increases, so slope increases. Okay, therefore see, what we require between t1 and t2, my slope has to be decreasing, because initially the velocity is more and then as time passes velocity is decreasing. Okay, thereby I draw something like this. And why I not turned over here? Because over here the displacement keeps on increasing. At this point the graph will turn. Okay, remember, when the velocity is becoming 0, then only graph can turn. It cannot turn when the velocity is non-zero. Okay, because, I mean, this is pretty intuitive, because if a body is not at rest, okay, how can it turn? Doesn't matter what amount of forces you are applying on it. Okay, so after this, what's happening is, see, a retarding force is acting between t1 and t3. Okay, therefore it will now gain velocity in the negative direction. Okay, we can say that it will gain speed in the negative direction. Initially the speed will be 0 and then speed will keep on increasing, but since the velocity this time is in the negative direction, the slope will be negative. But if you are confusing with the slope, the thing is, try to do with steepness. Steepness will if the speed is increasing, the steepness will always increase. Okay, so now the graph will turn. Okay, as you can see that initially the slope is pretty less, or the steepness is pretty less. Slope is negative because velocity is negative. Okay, but over here steepness keeps on increasing. As you can see, the slope is steepest at point t3. Okay, now again at t3 it has gained some speed in the negative direction. Okay, maximum speed in the negative direction. Okay, thereafter for interval t3 and t5 it is experiencing some force in the positive direction now. Okay, so what will happen is, this speed in the negative direction will keep on decreasing. Okay, due to this acceleration in the positive direction. Okay, and at t4, since the velocity is becoming 0, what will happen is, the speed or or we can say that the curve will have a slope 0. Okay, but remember, it will continue to move in downward direction. It will not change its direction at this point. Why? Because again, it is having maximum speed at this point. Okay, therefore it cannot change its direction. Okay, so it will keep on moving in the same direction, but with, how should slope change? Slope should decrease as the speed is decreasing. So steepness is decreasing, right? You can see over here the steepness is decreasing. This point is least steeper. Okay, so at this point the tangent will be horizontal, because over here velocity is again becoming 0. Now since the velocity is 0 over here, after this what will happen is, see, because the accelerating force in the positive direction was applied between T3 and T4. So after this, now it will start to move in the positive direction. So now it will change its direction, right? And how should it go? First of all, it has to be a curvilinear line. It cannot be a straight line, because in the time interval T4 and T5, my velocity is not constant, it is changing. Okay. Now what's happening is the magnitude of the, or velocity or the speed is increasing. So slope must be increasing, and since the velocity is in the positive direction, therefore slope will be positive for the entire interval, and it is increasing. So what we can draw, something like this. Okay, as you can see that initially the slope is minimum and it is becoming 0, and all points it remains positive. Okay, steepness increases. So I mean, if you are talking about the speed, you can think in terms of steepness. Okay, if you are talking about the velocity, then you need to consider whether the velocity is positive or negative. Okay, that will define whether the slope will positive or negative, right? So I think now these relations between Vt, Xt and At must be clear to all. Okay.